Okay, 2019 exam paper 2, question 3 was a probability question. So it says, in a population, the probability that a person had blue eyes is 0.7. One person is chosen at random from the population. What's the probability that this person does not have blue eyes? So what we said is the probability something happens is one value, but the probability something doesn't happen is 1 times its opposite. So in terms of the whole population that they have eyes is the value 1. So we know that the blue eyes is 0.7. So the probability that they don't have blue eyes, so they don't have blue eyes, is equal to 1, which is the whole population, take away the blue eyes. So 1 take away 0.7 is equal to 0.3. Okay, so your value is less than 1. It's between 0 and 1, so you know you're okay. Second one, 2 people are chosen at random. What's the probability that they both have blue eyes? So the probability that one of them will have blue eyes is equal to 0.7. Okay, the probability the second person has blue eyes, it's an independent event, so it's also equal to 0.7. But we want to know what's the probability they both have blue eyes. So both have blue eyes is that one has blue and the next also has blue. So in terms of probability, the and is equal to multiply. So in terms of this, you are going 0.7 times 0.7. I'm working it out in my head, right? So in terms of that, when you multiply 0.7 by 0.7, you get 0.49. So when you multiply the two, you get 0.49, which is a value still between 0 and 1, so you know you were right. If you had added the two values, you would have got 0.7 and 0.7, you would have got 1.4, and that should have triggered you into realizing that you had made a mistake, because you cannot get a value bigger than 1. Okay? Next part says 3 people are chosen at random. What's the probability exactly 2 of them have blue eyes? So we have 3 people, right? And their eyes can either be blue or not. So that's my first person. No, so even do that. So we have our start off point. We have blue or not blue. Next person has blue or not blue. Blue or not blue. Third person, blue or not. Blue or not. Blue or not. And blue or not. So we want to know what's the probability that exactly 2 of them have blue eyes. So if we look along our first branch of our tree, we've got 3 blues, so that doesn't count. If we go this way, okay, we get 1 go. So going this way, so we have a blue, and an N. So 2 of them have blue eyes. Third branch, you go blue, N, B. Yeah, so that works again. So blue, N, and B. Blue, N, and N doesn't count. N, B, and B works. N, B, and N doesn't. And N, N, and B doesn't, and N, N, and N doesn't. So the probability that exactly have 2 of them have blue eyes are these 3 options. So we've got 2 blue and 1 not, 2 blue and 1 not, and 2 blue and 1 not. Each of the choices are independent. So the fact that this one has blue doesn't affect or influence this one. This one has blue doesn't influence this, right? So your probabilities to get your blue was 0.7. To get your blue was 0.7. To get your N was 0.3. And so to go along this route, you had to go 0.7 times 0.7 times 0.3. Okay, this one we went 0.7, 0.3, 0.7. On this one, we had a 0.3, 0.7, and 0.7. So you get out your calculator and you multiply 0.3 by 0.7 by 0.7. So just let me do that. So on calculator, okay, I go 0.3 times 0.7 times 0.7, and I get 0.147. So each of these lines is equal to 0.147, right? So I've got a 0.147 for the first, 0.147 for the second, and 0.147 for the third. Now I have the choice of this, this, or this. So these are ORs. So we have the OR option. So you're adding the values. So you're adding 0.147 plus 0.147 plus 0.147. And you get the total. So the probability of having two of them having exactly two blue eyes is equal to 0.441. Okay, so how I would do it again is do out your tree diagram, which is very easy. Fill in your probabilities. The reason you're filling in the probabilities rather than just counting the end branches is the probabilities for blue and not blue aren't equal. If they're equal, you could just add up the end leaves. Okay, but this isn't equal. Okay, and then finally of that question, it says 4 people are chosen at random, one after another. What's the probability that the 4th person is the one to have the blue eyes? So the 4th person is the only one to have blue eyes. That means the first person has not got blue eyes, second has not got blue eyes, third has not got blue eyes, and fourth has the blue. Right, so the probability for not is 0.3. 0.3, 0.3, 0.7. And in terms of these, they all have to do it. So they all have to be ands. So we have not blue eyes and not blue eyes and not blue eyes and. So in terms of you working it out, you're going to multiply. So OR means add and means multiply. So again, you go back to the calculator. And in terms of this, you're going 0.3 times 0.3 times 0.3 times 0.7. And you get the probability of 0.0189, which is basically telling you that it's a very rare event that you would have 4 people and none of them will have blue eyes, especially because the blue eyes is 70% of the population. So that makes sense. Okay, so that was question 1.